Good day, everyone. Welcome to Maths with Gastin. I am Gastin Mapala. Today's example, we are looking at analytical geometry, grade 10, with an example here with coordinates of A, B, and C. They are given here as they are, as you can see at the diagram. And then it says here they are the vertices of a triangle ABC. So we've got a triangle here, triangle at A, B, and C. Okay, there you go. And then it says the P is a midpoint of BC. So it excuse me. So it means there's a P here somewhere. And then also you've got Q, that is a midpoint of AC. So you've got Q there. There is Q there. It's given in that coordinate. That's a midpoint as well. So it means this side it's also equal to this side as well. Even this side, they are also equal in terms of the length. Okay. All right. So let's have a look at the questions. Let's say question number 1 says find the coordinates of P. So therefore, coordinates of P, which is the midpoint of AC. Which is the midpoint of BC rather. Okay. So we've got B there. The coordinate is minus 12 is to 1. And then we also got C here, which the coordinates of 8 is 2, 1. So we can mark this x1, y1, x2, y2. Okay, as we discussed on our lesson video, that this is how we're supposed to mark them. Therefore, if we check on our formula sheet, we know the midpoint formula. This which is the point at P is going to be given by x1 plus x2 all over 2 is 2y1 plus y2 all over 2. Okay, so this would be the coordinates of P. Now let's do the substitution. X1 it's minus 12 plus 8 all over 2, then close bracket is going to be equals to y1, which is 1, plus y2, which is 1 all over 2. So therefore, all in all, this should give us, you should be able to have the minus 4 over 2 and then 2 over 2, which in all will give us the coordinates of P, which is going to be minus 2 is to 1. Okay, we've got the coordinates of P there. We're going to put them here on our diagram. Okay, now we got the coordinates of P. So now let's continue. Let's have a look at question number 2. Let me just mark them. This was number 1. So therefore, number 2 would be the coordinate of A. Okay, so A is unknown here, but then we have got a P, we have got a Q and C. Okay, therefore this is what you have here. Let me just illustrate here in terms of the diagram. You've got A there in terms of A and B, then you've got Q there, which is the midpoint. Okay, so Q is given by 3 is to 6, and then you've got C there, which is given by 8 is to 1. Okay, so if this is the midpoint, so this question basically is asking us what is known as a midpoint in reverse. So this is how you deal with midpoint in reverse. You know the coordinate at the midpoint, which is at Q, is going to be given by the value of x at A plus the value of x at C divided by 2. Then you would do the similar thing for y. The y at Q would be given by the coordinate of y at A plus the coordinate of y at C all over 2. Okay, so let's start here. What is the coordinate of x at Q is 3, which is equal to the coordinate of A of x at A. We don't know, it's given by A, plus at C it is given by 8 all over 2. Okay, then you do our cross multiplication. We're going to have a plus 8 is equals to 6. Okay, then you then you take it to the other side. When you jump the equal sign, it's going to be 8 minus it's going to be 6 minus 8 rather, which is going to give us minus 2. Okay, so here similar thing you would do for y. What is the coordinate of y at the midpoint? It's 6. Okay, is equals to the coordinate of y at a, it's b, plus the coordinate of y at c, it's 1, divided by 2. Therefore you will do the cross multiplication here. We should be able to have b plus 1 is equals to 12. Then we take 1 to the other side, is going to be 12, b is equals to 12 minus 1, which is given by b is equals to double 1, which is 11 rather. Therefore, we know the coordinates of a now is going to be minus 2 is to 1, 1, which is 11. Okay, now let's come to question 3. Question 3, it's asking us for the length of PQ, length of PQ. So this is given by the distance formula, which is going to be equals to square root of x at excuse me, is going to be given by x1 minus x2 all squared plus plus y1 minus y2 squared. Okay, so what are the coordinates of p? Coordinates of p, we calculated them. We know the coordinates of p, they're given by minus 2 is to 1. Then the coordinates of q, they are given by 3 is to 6. Okay, so basically they're asking us to find this distance here, basically. All right, okay, let's go ahead and do our substitution, straight substitution into the calculation. We're going to have x1, which is minus 2, which is the x at p, minus the x at q, which is 3 all squared, plus the x at p, which is the y rather, it's 1 minus 6 all squared. Don't forget the square root, guys. We make this mistake a lot, always forgetting the square root. Now we can go into our calculator, punch this into our calculator. Therefore it should be able to give us q is equals to 50, equals to 50. Okay, so that's how you deal with question number 3. Now let's go ahead and deal with question number 4. Let me just put the line here to separate these questions. Okay, question number 4 rather. They said find the gradient of PQ and the gradient of BC, then give a reason. Okay, so we know that gradient is related to parallel or perpendicular. So I think this is what they're asking us to give here. So the gradient of PQ would be given by y2 minus y1 all over the x2 minus x1. Okay, similarly, this should be given by what is y2 is going to be 6 minus 1 all over x2, which is 3 minus into minus 2. Okay, dealing with a negative, we must put a bracket there. Okay, so now if you go ahead and then please wait. Okay, guys, made a terrible mistake here. They are saying that they are then to PQ. Okay, all right. So if you were to punch this in your calculator, you should be able to have 5 all over 5, which is given to give you 1. So therefore the gradient of PQ, gradient of PQ should give you 1. Okay, all right, great stuff. So let's go ahead now, look for the gradient of AB. Okay. Gradient of AB, I'm just going to do a straight substitution, guys. We already have the coordinates of A and B. It's going to be 1 minus 11 all over A minus 12 into minus 2, which is going to give us a minus 10 over minus 10, which is equal to 1. Okay, so now they said we need to make a conclusion, a reason, therefore, because the gradient of AB is equal to the gradient of PQ. Therefore, these two lines, they are parallel. The lines are therefore parallel. Okay, great stuff. So now let's move to the next page because I don't have a space here anymore. On the next page, now the question is saying number 5. Number 5, it says find the equation of AC. So this is the line here, AC. We need to find this equation. Okay. All right, and we know the coordinates of excuse me, we know the coordinates of A. We said the coordinates of A is minus 2 is to 11. So these are the original coordinates of A. We calculated them previously. Okay, so right here we are going to use the equation of a straight line is there on our formula. She's going to be y minus y1. Any y coordinate that is there on our straight line is equal to the gradient of AC, and is going to be given by x minus x1. Okay, so therefore the gradient of AC is going to be given by, we need to find this one first. Gradient of AC is going to be given by y2 minus y1 all over x2 minus x1. I can just take the coordinates of AC there. I can say, okay, let this ones be coordinate number 2 at C, then at A is going to be coordinate number 1. So what is the y value at C is going to be 1 minus the y value at at C rather. Okay, no, y value at A, because we're saying the gradient of AC. Okay, so at A we're gonna have double 1, which is 11, all over x2, which is 8, minus into minus 2. Okay, this should give us negative 10 all over positive 10, which is going to be equals to minus 1. Okay, so therefore we've got the coordinates of we've got the gradient rather of AC. Therefore we can substitute into this formula of ours. Okay, that's not the proper line. So guys, we can substitute here into this formula. We can say y, then we're gonna choose any value. So let's choose q because it was a given, minus y1, which is at q. We can say or let me rather choose the coordinates of C, which is 8 is to 1, as my x1 and y1 to do my equation. So it's going to be 1 is equals to minus 1 is going to be given by minus 1, okay, is to x minus x1, which is given by 8. Therefore, if we put this in our, it will do the algebra here, multiply by this negative 1. We do a binomial. Binomial is going to be negative x. Negative 1 times negative 8 is going to be positive 8. Then we take this one to the other side to jump the equal sign. Therefore, it will change the sign. Minus x plus 8 plus 1. Therefore, this is going to be given by minus x is 2 plus 9. Then we can double check our equation by substituting any value that we didn't use. We can either substitute q rather. We can substitute 3, see if we're going to get the value of x of y rather as 6, and then we can also substitute the other value there, which is the coordinates of a, which is minus 2 is to double minus 2 is to 1 1. Okay, right? Therefore, this is how you would deal with this equation, guys. That was an example on analytical geometry. Please go through this question. You can pause the video and attempt to do this question on your own, and you can just view the solution therefore afterwards, so that you will be able to see if you are able to follow. If you can be able to do this alone without seeing, it means that you understand the concept. But if you don't, please make sure that you reach to us on the comment section below, or reach to us on our WhatsApp number. Make sure that we will be able to reach you and assist you, whether online or whether you want us to put or suggest any question that you would like us to do. And that's how you would deal with questions on analytical geometry. Please make sure that you watch the whole series starting from the lesson and until this example, so that you fully understand and you can maximize your chances of getting full marks on this chapter. I am Gastin Mapala, right here at Math with Gastin. See you on the next upload.